Hello to everyone. This is Shantan Kumar, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today topic is maxima and minima of functions of three variables. As we discussed in the previously, the maxima, minima functions of two variables, then how to find the solution. But today we are going to discuss that maxima and minima of a functions of three variables. That means the given function is involving three variables. One is x, y, z. If it is involving the three variables, then how to find the solution? We need to discuss. This is the problem. See, for example, it is given the function is a two variable, that we know that how to find the solution, that is based upon that to find the maximum value and minimum value with the help of that partial derivatives, first order and also the second order, to finding the extreme value, and again based upon the extreme value, we know that how to find the condition, whether the function is a maxima or minima or something that depend upon the saddle point or further investigation the condition. And today we are going to discuss the given function is having the three variables, then how to find the solution. Sometimes the given function is having like two variables and connected with another variable, that is by using the Lagrange's method of multiplies. But we are going to discuss that not by using the Lagrange's method of multiplies, that we are going to discuss the standard method, how to find the method by using the given function is having the three variables, that we are going to discuss today's class. Here, for example, the given function is a three variables, that is nothing but consider one is a x, y, z variable. And again, if it is a given the three variable, then the given equation is reduced to the two variables from the given function, that is a z is equal to. Then after reduce it to like that z in terms of x, y, again we need to follow that previous method to find the extreme value, that is with the help of the finding the extreme value, that is dou by dou x and dou by dou y, according to that is a method. And here, first of all, you find out what is the procedure, the local extreme values of the functions of two variables. Here, a point is a, b is said to be the stationary point of the function f of x, y, if the dou by dou x at the point of a, b is equal to 0 and dou by dou y at the point of a, b is equal to 0. Here, that finding the solution with the help of the dou by dou x and dou by dou y, the stationary point a, b is said to be the saddle point. And again, here with the help of the given point, that is whether the function is neither local function or that is nor a local minimum or locally that is a maximum value. And again, we need to find out what is the procedure to find the locally extreme value of the function, that is f of x, y is a function. Here, first of all, we need to find out what is dou by dou x and also dou by dou y. That is nothing but the given function is treated as f, and with the help of that f, you need to find out what is the derivative with respect to x and y as a partially with respect to that is a function, that is dou by dou x. And after getting the dou by dou x, we need to find that equating the 0, that is dou by dou x is equal to 0, dou by dou y is equal to 0. By solving these two equations, we get sum of the points. The sum of the points are considered a1, b1, r, a2, b2, and similarly like that. And sometimes these are the points are also treated as x1, y1, x2, y2, something depend upon the given equation. For example, if it is only one point, you need to find out directly. And if it is given that something more than the 1 point or like the 2 points, 3 points like that, you need to further the values. And again, after getting the stationary points, then for once again, we need to find out, calculate with the help of that r, s, t. The meaning of r is nothing but the second derivative with respect to partially x as a, that is a dou square f by dou x square, and s is nothing but that is a dou square f by dou x dou y, and t is nothing but that is a dou square f by that is a dou y square. That is the meaning of, first of all, we need to find out that first order partial derivatives, and again the second order partial derivatives. One is a p, q, and second one is a r, s, t only. And again, after getting that r, s, t, then we need to find out at the stationary point, that is at each stationary point, that is r we need to calculate, that is r is equal to that is a dou square f by dou x square at the point of a1, b1, and s is also we need to find out that is a dou square f by that is a dou x dou y at the point of a1, b1, and t is equal to that is a dou square f by dou y square at the point of a1, b1. Like this procedure we need to find out. And again, next one, after getting that is a r, s, t, then we need to find out what is the RT minus S square is a condition, that is a value. And if it is RT minus S square at the point of A1 comma B1, if it is a conclusion the stationary points A1 comma B1 from the following table, we need to understand that is a result that according to that conclusion, here RT minus S square is greater than 0, the function is said to be that is a minimum value, and whereas it is R is also greater than 0. And if it is RT minus S square is greater than 0, and also that is R is less than 0, the function is said to be that is a locally maximum value. And for example, RT minus S square is less than 0, the function is said to be no locally maxima or locally that is a minimum value. That is nothing but it is a definition is called as a saddle point only. And if it is RT minus S square is equal to 0, and also if it is R is equal to 0, nothing can be said about the locally maximum or locally minimum. It is required that further investigation it is required. These are the basic steps we need to required to find that at the given function is a f is a function. Here the equation is involving like the three variables. First we need to converting it to the two variables. That is with the help of the given function z is equal to, you need to write that x comma y, and after assume that there is a function f, we need to find out that is a first order derivative with respect to x comma y, and again the second order derivative with respect to x comma y, that is nothing but dou f by dou x and dou f by dou y, and similarly the dou square f by dou x square, dou square f by dou x dou y, and dou square f by dou y square, and that is nothing but you need to find out at the each stationary points according to the procedure what is the value of r, s, t. And again, after finding that at each stationary points, once again we need to calculate that is RT minus S square. And if it is RT minus S square is greater than 0 and is R is less greater than 0, the function is said to be minimum value. And again, RT minus S square is greater than 0 as well as R is less than 0, the function is said to be that is a locally maximum value. And RT minus S square is less than 0, the function is a saddle point, that is neither the maxima locally or maxima minimum. And again, RT minus S square is equal to 0 or R is equal to 0, that is a further investigation it is required. This is the procedure involved in that function. The given equation is involving in terms of the three variables. Now we'll go to discuss according to that one of the problem, then how to find the solution that is based upon that. And before going to discuss here, that repeat the step if it is a procedure is a more than the 2 points, that is a 4th step and 5th step and also 6th step for it all the stationary points are also. And by using the condition, we need to find out whether the function is a locally minimum value or locally that is a maximum value. Now, we'll go to discuss one of the problem based upon this is the given function is like the three variables, then how to find the solution. Here, for example, find the three positive terms whose sum is 100 and whose product is a maximum. That means when we are going to observing in this problem, we need to find out what is the function of the maximum value. That is with the help of the procedure, the given equation is here what is it? The three variables are which is involving. One is x comma y comma z, and it is x comma y comma z are the three that is a positive numbers, and according to it is considered the three positive numbers whose sum is 100, and based upon that assume we need to consider x plus y plus z is equal to that is 100, and by using this equation that is a z is equal to, we need to converting that is in terms of the two variables. Why? Because here in this problem that is involving the equation is a three variable, but we need to converting into the two variables, and according to the two variables the equation is z is equal to that is a converted 100 minus x minus y only, and the function is a consider f of x comma y is equal to xyz. Why? Because the function is a product is a maximum. That product is nothing but you treat it as xyz only. Therefore, in this f of x comma y comma z is equal to you treat it as f of x comma y only. Therefore, xyz in this equation z, we know that that is the sum is equal to that is x plus y plus z is already given that 100. From that z is equal to that is 100 minus of x minus plus y. Therefore, we need to replace here that is xy into 100 minus x minus y. Therefore, the simplification of this equation is a 100xy minus x square y, that is a minus x into y square. Therefore, we need to find out whether the function is a for maxima or minima, that is with the help of the finding the first extreme value. That is before going to extreme value like that, we need to find out what is the stationary point. And the stationary point is, we know that that is the finding that dou f by dou x and dou f by dou y. Therefore, the dou f by dou x is equal to in the equation, by equating that derivative with respect to x as a partially, the equation is reduced to 100 into y minus 2x into y minus y square is equal to 0. Why? Because it is a partial derivative with respect to x. That means if we treat it as a y as a constant. And from this equation, once again, it is equal to, that is a y take out common, that is 100 minus 2x minus y is equal to 0. And similarly, that is dou f by dou y is also y with respect to derivative as a partially with respect to y, you treat it as x is a constant. Therefore, here also that is 100x minus, that is a x square minus 2x into y is equal to 0. And once again, we need to take out common x is outside, that is a x into, that is a 100 minus x minus 2y is equal to 0. Therefore, you treat it as equation 1 and equation 2 only. Therefore, by solving this is the equation 1 and 2, therefore, that is a 100 minus 2x minus y is equal to 0 and 200 minus 2x minus 4y is equal to 0. Because of, we are going to cancelling that is x, due to that reason, the second equation is multiplication with that is a 2 only. Therefore, by solving this equation 2, therefore, we obtain that clearly, that is a 3y is equal to 100, therefore, y is equal to 100 by 3 only. Therefore, by using this one y value, once again when we are going to replace in the equation 1, therefore, you automatically get that x is also 100 by 3. Therefore, here the stationary points are corresponding like that x comma y is equal to 100 by 3 comma 100 by 3 is a value. Therefore, here at this 100 by 3 comma 100 by 3, that is x comma y value, when now we need to replace in that what we are treated as L comma M comma N only. Here that L comma M is nothing but, as I am given that according to the procedure, you treat it as L is equal to R, and again M is equal to that is a S and N is equal to that is a T only. Therefore, it is according to, you need to follow that is a L is equal to that is a dou square f by dou x square is nothing but once again derivative with respect to x as a partially on that, that is a dou f by dou x is equal to, you obtain that minus 2y. And again, at the point of this L, that is a dou square f by dou x square, that stationary point, that is a 100 by 3 comma 100 by 3, the final value you obtain that clearly, that is a minus 200 by 3 is a value. And similarly, now we need to find out what is M. That M is nothing but, we know that that is S, that is according to the dou square f by dou x dou y is nothing but whatever we know that that is a dou f by dou y. On this, once again we need to with respect to x as a partially, that is a dou by dou x of dou f by dou y is equal to, that is 100 minus 2x minus y. Now, we need to replace at the stationary points of, that is a dou square f by dou x dou y at the point of 100 by 3 comma 100 by 3. According to that simplification, you get that clearly 100 minus 200 by 3 minus 200 by 3 is equal to, that is a minus 100 by 3 only. And now we need to find out what is the n value. That n is nothing but according to the dou square f by dou y square. That means whatever we know that that is a dou f by dou y, once again on that with respect to y as a partially, and again after getting that one, you need to replace it. N is also like that 100 by 3 comma 100 by 3. The solution, it is also the value is a minus 200 by 3 only. And now we need to calculate what is the value of that Lm minus n square. That is nothing but, here according to, I am given the working rule, you comparison Rt minus s square is nothing but, that is a Lm minus n square is a value. Therefore, by comparison with the help of that Lm minus n square is equal to, that is Rt minus s square, clearly you obtain that value is a 100 whole square by 3 is a value. Therefore, this 100 by whole square by 3 is a value is nothing but it is a positive value. Therefore, according to the stationary points at the maximum value, it is 100 by 3 comma 100 by 3. Therefore, here once again that z value is nothing but 100 minus 100 by 3 is equal to, that is 100 by 3 is a value. Therefore, here according to the function is also that real numbers are here given that according to the problem is a x, y, z. Therefore, here x comma y comma z are clearly, that is 100 by 3 comma 100 by 3 comma 100 by 3 is a value. Now, we'll go to discuss one other problem based upon this is the method. Here, that is a rectangular box open at the top to have, that is volume is a, that is a 32 cubic feet. Find the dimensions of the box, required least material for its construction. That means when we are going to observing this problem, here we need to understand what is the dimensions of the box and what is the meaning of here surface of the given box also. Therefore, let us assume that x is x comma y comma z be the dimensions of the box and s be the surface of the box, and according to the surface of the, if it is a considered that is a rectangular box, the rectangular box of the surface is nothing but, according to, we know that that is the 2xy, that is a 2xy plus that is a 2yz plus 2zx is a value. But in this problem, it is a given problem is a one side it is open. Therefore, according to that one side it is open is nothing but, from the 2xy is a consider, it is xy plus 2yz plus that is a 2zx is a value. Therefore, according to it is the surface of the given function is a consider xy plus 2yz plus 2zx is a value, and one other given, it is a value of the rectangular, it is nothing but, it is a 32 cubic feet is a given. Therefore, the value is nothing but, according to the rectangular, that is x comma y comma z, if it is treated, the product of the three variables, that is x into y into z, is equal to that is 32. Therefore, according to, if you are going to following with the help of this is the two variables to finding the maxima or minima, here whatever we know that is a z is equal to, we need to find out what is z value is nothing but, that is a 32 by that is a x comma y, that is x into y. Therefore, by using this is the z is equal to 32 by xy, we need to replace in the surface equation. Therefore, if it is a surface equation is treated as s is equal to that is a xy plus 2yz plus 2zx is equal to, in that whatever we obtain that z is equal to that is a 32 by xy, we need to replace here. Therefore, xy plus 2y into z is equal to, as we know that that is a 32 by xy plus 2 into, once again the zx is nothing but, that is a 32 by xy into x. Therefore, here we need to cancel that in the middle of the term, that is y cancel, and again the last equation is also xx cancel. Therefore, finally the surface of the equation is we obtain in the two variables, one is a xy plus 64 by x plus 64 by y only, and this is the consider that is the surface of the given function in the two variable. And once again, we need to find out what is the stationary points. And because of the stationary points, we need to find out with respect to x and also y as a partially. Therefore, here with the help of that s is equal to, we need to find out what is the dou s by dou x and dou s by dou y. Therefore, the dou s by dou x is nothing but, according to, with respect to at the time of the dou s by dou x is equal to, we need to derivative with respect to x as a partially, but treated y as a constant. Therefore, according to the dou s by dou x is nothing but, it is a value is y plus that is 0 minus 64 by what is that here, minus 64 by that is a x square. And similarly, we need to find out what is the dou s by that is a dou y. At the time of this one, we need to find out what is the v with derivative with respect to y as a partially. That means we treat it as x is a constants. And once again, it is nothing but, the dou s by dou y is nothing but, that is x minus that is a 64 by that is a y square. And after getting these are the two first order with respect to x comma y equation, we need to equate the 0 by solving the stationary points. Therefore, that is a y minus 64 by x square is equal to 0. And similarly, x minus 64 by y square is equal to 0. Therefore, by solving these equations, clearly we obtain that the stationary points are x comma y is equal to 4 comma 4 only. And with the help of this x comma 4, once again we need to find out what is L comma M comma N. Here also same, that L is nothing but you treat it as R, and M is nothing but you treat it as a, that is a T, and again N is nothing but you treat it as a S only. Therefore, with the help of this one, we need to find out what is the Ln minus M square. Therefore, according to by using this condition, we need to find out Ln minus M square is nothing but, that is a value is equal to, that is a 128 by x cube into 128 by y cube minus 1 is equal to 0. Therefore, according to, once again, this is the equation, we need to obtain, it is equal to, by solving that, it is a function is a L maximum value. Therefore, it is x is equal to 4 and y is equal to 4. Therefore, the conclusion of that xyz is equal to, that is a given surface value is a 32, but whatever we obtain, that is x is equal to 4 and y is equal to 4, when we are going to replace in that xyz is equal to, that is a 32, therefore we clearly obtain that z is equal to, the value is a 2 only. Because of here, it is nothing but xyz is equal to x, y, z is equal to 32. As we know that is x is equal to 4 and y is equal to 4, the remaining function is z is equal to 32. Therefore, from this equation, z is equal to, the value is a 2 only. Therefore, this is the procedure to find out when the given functions are the three variables, then how to find the value in the how to reduce it to two variables, and again how to find the solution. For example, if you are going to discuss that one other problem, it is equal to find the volume of the largest rectangular parallelepiped that can be inscribed in the ellipsoid is a condition. Therefore, here also, before going to discuss here, we need to understand what is the volume of the rectangular parallelepiped. Therefore, the rectangular volume of the rectangular parallelepiped is nothing but if it is considered length, breadth, and height of the equation is equal to, that is a 2x comma 2y comma 2z. Therefore, the volume of the rectangular parallelepiped is nothing but there is a 2x into 2y into 2z. That is nothing but the product of the length, breadth, and height is equal to, here the given equation is a 8xyz is a value. Now here that v is equal to, given that 64, that is x square into y square into z square. Why? Because the equation is x square plus y square plus z square by c square is equal to 1 is given already. Therefore, here we need to find out what is the z square by c square. Otherwise, we need to find out what is the z square. Therefore, from this equation, the z square is nothing but, according to the equation, is 1 minus x square minus y square, x square by a square minus y square by b square only. Because of that z square is according to from the given, that is a ellipsoid, that is a rectangular parallelepiped. Therefore, from the equation, we need to find out what is the value of that dou y by dou x and dou y by dou y and dou y by dou z only. Therefore, corresponding the dou y by dou x and dou y by dou y and dou y by dou z, we obtain it clearly, that is a 64 into x square into, that is x square y square minus x power 4 into y square by a square minus x square into y power 4 by b square. And one other equation is also 2x into y square minus 4x cube into y square by a square minus 2x into y power 4 by b square. And finally, that is a dou by dou y is also, that is a 64 into x square into 2x square y minus 2x power 4 by y square minus, that is a 4x square, that is y cube by b cube. And by using this equation, that is a dou by dou x and also dou by dou y, according to the working rule, we need to find out that equate the 0. That is nothing but one of the equation is a 2x square by a square plus y square by b square is equal to 1. And one other equation is also x square by a square plus 2y square by b square is equal to 1. Therefore, by using these two stationary points, that is the two equations, when we are going to find solving that equation, we clearly obtain that is x is equal to, that is a by root 3 and y is also b by root 3. And these are the considered, that is the stationary points. Therefore, x comma y is assumed, that is a by, that is a root 3 comma b by root 3. Now, we need to find out what is the value of like L comma M comma N, otherwise R comma S comma T only. Therefore, according to the procedure, it is L is nothing but dou square by dou x square, and M is nothing but, that is dou square by dou x dou y, and N is nothing but, that is dou square by dou y square is the value. Therefore, it is nothing but, clearly the meaning of it is equal to, first one is R and second one is S, and again the third one is a t value. Therefore, according to that, the second derivative with respect to x as a partially, we obtain that clearly, that is dou square by dou x square is equal to 64 into c square of, that is 2y square minus 2x cube y by a square minus 2y power 4 by b square. And similarly, that is m is equal to, that is nothing but s is equal to the dou square by dou x dou y is equal to 64 into c square of, that is 4xy minus 8x cube into y by a square minus 8xy cube by b square. And finally, we need to obtain that, that is t is equal to, that is n is equal to dou square by dou y square is equal to 64 c square into 2x square minus 2x power 4 by a square minus 12x square y square by b square is a value. Now, after getting these are the L comma M comma N, that is nothing but R comma S comma T. Now, we need to replace in this L comma M comma N, otherwise R comma S comma T at the point of stationary points. That stationary points are already, we know that there is a by root 3 comma b by root 3. Therefore, by using these stationary points a by root 3 comma b by root 3, the values are according to R is less than 0 as well as, that is RT minus S square, that is nothing but dou square by dou x square is less than 0, and Ln minus M square is greater than 0. The function is said to be, that is a maximum point. according to the condition, it is nothing but it is alternate, that is RT minus S square, that is RT minus S square is greater than 0 as well as R is less than 0 in other terminology. Therefore, it is a function is said to be maximum at the point of a by root 3 comma b by root 3. Now, we need to find out what is the volume of the given rectangular parallelepiped. Therefore, by the conclusion of this one, whatever we know that according to the previous condition, by using this value, we obtain that by using these are the values of a comma a is equal to a by root 3 and b by root 3, we obtain that v is equal to, that is 8 apc by, that is root of 27 is a value. Now, we need to discuss one other problem, that is find the minimum value of, that is x square plus y square plus z square, given that xyz is equal to a cube. But in this problem, clearly we identify that equation from the second one, that is z is equal to, that is a cube by, that is xy is clearly we obtain. By using this, is the z is equal to a cube by xy, when we are going to replace in the first equation, that is x square plus y square plus z square. Therefore, the equation is reduced to like that, x square plus y square plus z square, and again according to this equation, there is a plus a power of 6 by, that is x square y square, because of that z is nothing but a cube by xy, but that is a z square is equal to, that is a power of 6 by, that is x square by into y square. By using this value, it is clearly the function is reduced to x square plus y square plus a power 6 by, that is x square y square. This is nothing but the equation is clearly we obtained in terms of, that is two variables only. Now, according to the procedure, we need to find out what about the stationary point. Therefore, the stationary points are calculating with the help of the dou by dou x and dou by dou y. Therefore, in that equation, when we are going to obtain the dou by dou x, that means you treated y as a constant. The dou by dou x is equal to 2x minus 2a power 6 by x cube into y square. And similarly, we need to find out, that is dou by dou y. That means you derivative with respect to y as a partially, that means treated x as a constant. Therefore, the equation is reduced to 2y minus 2a power 6 by x square into, that is y cube. Now, by solving these two equations, we obtain the stationary points. Therefore, by solving these two equations is nothing but, first equation is a 2x minus 2a power 6 by x cube into y square, and one other equation is a 2y minus 2a power 6 by x square into y cube. By solving these two equations, we obtain that clearly x is equal to a and y is equal to a. That is nothing but clearly according to by solving here, that is a 2x power 4 into y square minus 2a power 6 is equal to 0, one equation. And again the second equation is also 2x square into y power 4 minus 2a power 6 is equal to 0. From this first equation, here the 2 to cancel, therefore 2 to cancel. And again it is also x square is also cancelled in the first equation. Therefore, clearly we obtain, that is a x square x power 4. Yeah, here by solving that x power 4 y square is equal to, that is a power 6. And again the second equation is also x square into y power 4 is equal to a power 6 only. Therefore, it is both are the a power 6 cancel. By equating these two equations, that is a x power 4 into y square is equal to x square into y power 4. Therefore, once again that y square, and again that here y square is cancelled, that x square and it is also x square is cancelled. Therefore, the equation is nothing but x square is equal to, that is equal to y square. That is nothing but x is equal to y. Therefore, by using that x is equal to y is nothing but, when we are going to replace in any one of the equation, we obtain that x is equal to a and y is equal to a is also value. Therefore, by using this is the stationary points x is equal to a and y is equal to a, when we are going to replace L comma M comma N, that is nothing but R S T in alternate terminology. Therefore, that is RT minus S square, that is nothing but LM minus, that is a N square. Therefore, with the help of that equation at the point of the stationary points a comma a, that is a RT minus S square, otherwise Ln minus M square, the value is clearly greater than 0. And moreover, that is L is also greater than 0 at the stationary points. According to the working rule, the given problem is the function is a minimum value at the point of a comma a only. Therefore, if we require the minimum value of the given function, according to the equation is a square plus y square plus a power 6 by, that is a square into a square. The final solution we obtain the minimum value is 3a square is the value. Now we'll go to discuss one other problem, that is by using that in the trigonometric, that is in angle between the two variables or three variables, that is find the stationary points of the u of x comma y is equal to sin x into sin y into sin of x plus y, where that x is lies in between 0 to pi and y is also lies in between 0 to pi, and find the maximum value of the given function. Therefore, if it is a function is considered u is equal to sin x into sin y into sin of x plus y, that is lies in between x is 0 comma pi, and moreover that y is also lies in between 0 to pi. Therefore, according to, we need to find out what is the stationary point. Before going to stationary point, we need to find out what is the first order with respect to x and also y only. Therefore, by using this equation, when we are going to applying the first order with respect to x and also y as a partially, by solving according to this procedure, that is by using the component and multiple angle formula, here finally the equation is reduced to, that is the stationary points are clearly, we obtain that x is equal to pi by 3 comma y is also pi by 3 is the value. Therefore, by using these are the stationary points at x is equal to pi by 3 and y is equal to pi by 3, when we are going to replace in the L comma M comma N, that is nothing but R comma S comma T only. Therefore, by using this equation, once again we need to find out what is the L, that is nothing but what is the R value. Therefore, it is nothing but R is nothing but the dou square U by dou x square is nothing but, that is a dou square U by dou x square, that is a 2 into sin y into cos of 2x plus y. And we know that that is x is equal to root pi by 3, root 3 by 2, and y is also root 3 by 2. That is x is equal to pi by 3 and y is equal to pi by 3. Therefore, the 2 into sin y, that is a 2 sin pi by 3. Therefore, that pi by 3 value is that is root 3 by 2. And again, cos of 2x plus y is also nothing but, that is a 2 pi by 3 plus pi by 3 is a value. That is nothing but cos pi is a value. The value of that cos pi is equal to, the meaning is equal to minus 1. Therefore, here after that simplification, the value of L is equal to, clearly we obtain that minus root 3 is a value. Now, we need to find out what is M, that is nothing but, that is R T S. Therefore, R S T. Therefore, according to that, M is equal to, that is a dou square U by dou x square is nothing but cos y into, that is a sin of 2x plus y plus sin y into cos of 2x plus y. Once again, by using that sin a cos b plus cos a sin b, the value is nothing but sin of a plus b. By using that multiple angle formula, it is equal to, clearly by here sin of 2x plus y is the value. Once again, when we are going to replace that x is equal to pi by 3 and y is equal to pi by 3, the equation is a 2 into sin of 2 into 2 pi by 3 plus 2 pi by 3 is nothing but, that is a 4 pi by 3. Therefore, sin of 4 pi by 3 is nothing but minus root 3 by 2 is the value. And similarly, we need to find out what is the n value. That n is nothing but, as we know that, that is nothing but dou square u by dou y square. That is nothing but, according to with respect to y is a partially on dou u by dou y. Therefore, the value is equal to 2a sin x into cos of x minus y. Once again, we need to replace that x is equal to pi by 3 and y is equal to pi by 3. Therefore, that is a 2 sin pi by 3 and cos of, that is a pi value. Therefore, according to cos 0. Therefore, the value is equal to, that is a 2 into root 3 by 2, and again minus 1 is the value. Therefore, the value is equal to, once again, that is a minus root 3. Therefore, according to by using this condition, when we are going to apply observing, the condition is RT minus S square is the RT minus S square is greater than 0, as well as R is less than 0. That is nothing but ln minus m square or ln minus n square, or L is the less than 0. That is nothing but RT minus S square is greater than 0, as well as R is less than 0. Therefore, the function is said to be maximum value at the point of x is equal to pi by 3, comma y is equal to pi by 3. But we need to require what is the maximum value. Therefore, according to that, given problem is sin x, sin y, and again sin of x plus y. By using that condition, it is a root 3 by 2 and root 3 by 2 and root 3 by 2. When we are going to replace these the stationary points in the given function, therefore, the final value is 3 into root 3 by 8 is the value. Now we'll go to discuss one other point, that is find the points on the surface, that is z square is equal to xy plus 1 that are nearest to the origin. That means here we are going to follow with the help of the converting into two variables. But here that z square is equal to xy plus 1 is given that directly, but we need to find out what is the one other equation. That equation is obtained, that is the nearest to the origin. That if it is a consider the two point is x comma y comma z, it according to that nearest point is nothing but you consider that is the origin, that is 0 comma 0 comma 0. Therefore with the help of that 0 0 0 and one other is x comma y comma z, when we are going to consider that is the equation of the circle, that is a square root of that is x minus 0 whole square plus y minus 0 whole square plus z minus 0 whole square. Therefore that is a root of x square plus y square plus z square. But in this equation, we know that the z square is already given the function, that is xy plus 1. Therefore, by using the given equation, that is the z square, when we are going to replace in this equation, there is a square root of x square plus y square plus z square is nothing but LHS squaring on both sides, that is a square root is eliminated, that is a p square is equal to x square plus y square, that is a plus xy plus 1. Here it is clearly we obtain in terms of that two variables. Therefore, from this equation, that is r is nothing but that is a dou square by dou x square, that is a similarly that s is nothing but dou square by dou x dou y, and t is nothing but dou square by dou y square. That is nothing but here f is a function is given that consider assume in terms of that p. Therefore, that is in price of that f is equal to, you need to replace that is a p. Therefore, that is a dou square p by dou x square and dou square p by dou x dou y and dou square p by dou y square is a value. And by using this equation, we need to find out first of all what is the stationary points. And with the help of the stationary points, clearly we obtain that by solving the dou p by dou x and dou p by dou y is equal to 0. We obtain that clearly, that is x is equal to y is equal to that is equal to 0 comma 0 only, clearly by observing. Therefore, at the stationary point that is 0 comma 0, when we are going to replace in that condition, the value is equal to plus or minus 1 only. And once again, we need to find out what is the r comma s comma t only. Therefore, according to the derivative, that fourth equation with respect to x and y as partially, that r is equal to 2 by 2p is equal to 1, and s is nothing but 1 by 2p is equal to 1 by 2, and again the t is also 2 by 2p is equal to 1. Therefore, with the help of that r comma s comma t, when we are going to check the value of that rt minus s square, here clearly that is a 1 minus 1 by 4 is the value is a 3 by 4, which is always greater than 0. Therefore, it is a conclusion of this one, rt minus s square is greater than 0. Therefore, the equation is said to be that is a minimum value. Therefore, it is a minimum values are you obtain that according to that is 0 comma 0 comma 1 and 0 comma 0 comma minus 1 is the value. And next one, find the shortest distance from the origin to the surface x by z square is equal to 2, and where we are going to observing this is also same the previous problem, that is equal to, from this equation we need to find out what is the z square in terms of x comma y. Therefore, the z square is nothing but you get that there is a 2 by that is a x into y only. And again it is also given that shortest distance from the origin is nothing but according to the d is equal to in that square root of that is x square plus y square plus z square. Therefore, d square is equal to x square plus y square plus z square. Therefore, we know that given the condition is z square is equal to that is a 2 by xy. Therefore, that equation you need to replace in that f d square. Therefore, x square plus y square plus 2 by x is the value. Therefore, with the help of this is the function that is f. Therefore, when we are going to finding with respect to x and also y as a partially, that is a dou f by dou x is equal to clearly that is a 2x minus 2 by that is x square y, and with respect to y as a partially, similarly we obtain that fy is equal to 2y minus that is a 2 by x square. And once again we are going to solving this is a dou f by dou x is equal to 0 and dou f by dou y is equal to 0. By solving these two equations, therefore we obtain that x is equal to plus or minus y only. Therefore, the stationary points are, it is assumed that p1 is equal to 1 comma 1 and one other p2 is equal to consider 1 comma minus 1. Therefore, once again we need to find out what is the r comma s comma t, that is nothing but that is fxx, fxy and also fyy. Therefore, according to that, at the point of 1, 1, the value of the L is equal to 6 and m is equal to that is 2 and n is equal to 6. And similarly, that is ln minus m square is nothing but you treat it as that is equal to rt minus s square. Therefore, that rt minus s square is clearly obtained which is a greater than 0. And moreover, it is rt minus s square is a greater than 0 is nothing but it is a function is a maximum value. But we need to find out what is the shortest distance is nothing but the square root of that is 1 plus 1 plus 2. Otherwise, the total value is equal to that is a 2 value only because of that is 1 comma 1 comma minus 1 or 1 comma 1 comma root 2 is a value. Next one, find the minimum value of x square plus y square plus z square when ax plus by plus cz is equal to p. Therefore, here also we need to find out what is the minimum value. And once again, it is also the given that two functions are connected, but according to, we are going to discuss that is a converting into two variables only. Therefore, here by observing this equation, in the second equation is clearly z in terms of that is a x comma y. Therefore, that cz is equal to that is a p minus ax minus by. Therefore, z is equal to that is 1 by c into p minus ax minus by is a value. That is from the second equation we obtain that clearly that is equal to z value. Now, we need to consider what is the f function. Therefore, the f function is nothing but in terms of x comma y with the help of that z value, that is x square plus y square and again plus z square is equal to, you obtain that x square plus y square plus 1 by c square into p minus ax minus by of whole square. Therefore, again we need to find out what is the values are stationary points. The stationary points are, we need to know that how to find the value, that is dou f by dou x is equal to 0 and dou f by dou y is equal to 0. Therefore, the dou f by dou x is nothing but that is 2x minus 2a by c square into p minus ax minus by, and dou f by dou y is equal to clearly that is 2y minus 2b by c square into p minus ax minus by. Now, we need to solve that f dou f by dou x and dou f by dou z is equal to 0. And before going to discuss here, we need to find out what is the value of the dou square f by dou x square and dou f by square by dou x dou y and dou square f by dou y square. And with the help of that equation, once again we need to calculate what is the dou square f by dou x dou, that is dou f by dou rt minus s square, that is ln minus m square. Therefore, by solving that equation, clearly we obtain that is equal to x is equal to, these are the values, and y is equal to b by c square into p minus ax minus by. And again, here, when we are going to find out by using this is the y value, we need to find out what is the x value. Therefore, by solving that second and third equation, clearly we obtain that y is equal to bx by a, but we obtain that clearly that is a b value. Therefore, by using that value of here, we obtain that y is also that is a bp by a square plus b square plus c square, and x is equal to ap by a square plus b square plus c square. Therefore, substitute these are the x comma y values in that whatever the given equation connected, that is ax plus by plus cz is equal to p. Therefore, clearly obtain that the equation is a pc square by a square plus b square plus c square. Therefore, here the minimum value is nothing but one of the x value is the ap by a square plus b square plus c square, and y is also nothing but that is a pp by that is a square plus b square plus c square, and z is also you obtain it clearly that is a cp by that is a square plus b square plus c square. Therefore, the equation of the minimum value is nothing but f is equal to, you replace in the equation, you obtain that finally with the help of this is a x comma y comma z, that is a p square by that is a square plus b square plus c square is a value. Now, we need to find out that is a similarly find the rectangular parallelopiped, that is a maximum value that can be inscribed in the sphere. And here also we need to identify what is a rectangular parallelopiped, what is a sphere equation. And according to the rectangular parallel here, the sphere equation is nothing but it is x square plus y square plus z square is equal to a square. And again that rectangular parallelopiped, it is a volume is nothing but that is x comma y comma z, that is a product of x into y comma z. Therefore, it is a x square plus y square plus z square is equal to a square. Therefore, from this equation, it is a getting that z square is nothing but that is a square minus x square minus y square. Therefore, that z is equal to the square root of a square minus x square minus y square. Therefore, by using this z value, when we are going to replace in the equation of that is xyz in the value, therefore x into y into that is a root of a square minus x square minus y square. Therefore, when you are squaring on both sides, there is a value, that is a v square is equal to x square into y square into, that is a square minus x square minus y square. Therefore, once again we need to solve that equation, that is a dou by dou x and also dou by dou y, and similarly r comma s comma t, and by solving these are the two equation, and again you solve that, that is stationary points. The stationary points are clearly, you obtain that yx is equal to a by 3, a by root 3, and y is equal to a by root 3. And again, after getting these are the stationary points, now we are going to replace in that, that is z value, it is nothing but, it is also z is equal to similarly a by root 3. These are the stationary points, or critical points are nothing but, that is a by root 3 comma a by root 3. Now we need to find out what is the r comma s comma t only. That r is nothing but, as we know that, that is a dou square by dou x square is nothing but 2a square into y square minus 2l into x square into y square minus 2 into y power 4, and s is nothing but dou square by dou x dou y is also, that is a 4a square into xy minus 8x cube into y minus 8 into x into y cube. And similarly, with respect to y as a 2 times, that is a dou square by dou y square is equal to, that is the meaning of t is equal to 2a square into x square minus 2x power 4 minus 12 into x square y square. By using this is the r comma s comma t, when we are going to replace in the stationary points, that is r is nothing but minus 8 power 4 by 9, and which is always less than 0, whereas provided a is greater than 0. And similarly, s is also at the point of a by root 3 and a by root 3, the value is equal to minus 4a power 4 by 9. And similarly, t is also, the value is equal to minus 8a power 4 by 9 only. The conclusion of here, that is r comma s comma t, that is rt minus s square is always greater than, which is a 0, for by taking that a is any positive value. And therefore, it is a volume of that, that is a v square, as hence that v is a maximum at a by root 3 comma a by root 3. Therefore, volume is maximum for function x is equal to y is equal to z. Therefore, the conclusion value is equal to a by root 3. Therefore, the rectangular parallelepiped of the volume of the rectangular parallelepiped is nothing but, it is x by z is required. Therefore, the product of x is equal to y is equal to z is a by root 3. Therefore, x by z is also a by root 3 of whole cube is a value. That is nothing but a cube by 3 into root 3 is a value. Therefore, by conclusion of this one, it is also that divided by, here one other problem, it is a divide 24 into 3 parts such that the continued product of the first square of the second and the cube of the third is a maximum. And when we are going to observing, this is also problem is the sum of the 3 parts. For example, if it is a consider the product parts is x comma y comma z are the 3 parts, the sum is equal to given that x plus y plus z is equal to 24. Therefore, once again given the continued product of the first square of the second and cube of the third is nothing but, you assume that f of x comma y comma z is equal to, that is x cube y square into z. While we are going to observing here, the two functions are given, therefore we need to converting into two functions, that is a two variables only. By observing this is the equation, the second equation is x plus y plus z is equal to 24. From that equation, that is z is equal to, you obtain that 24 minus x minus y. Therefore, when we are going to replacing this f of x comma y, when we are converting into two variables, the equation is converted x cube into y square of, that is a 24 minus x minus y. Therefore, now we need to find out what is the stationary points. For the purpose of here, that is r is equal to, we need to find out, that is a dou by dou x, and s is equal to, that is a dou square by dou x dou y, and t is equal to, that is a dou square by dou y square. Therefore, rt minus s square, or before going to discuss that one, we need to find out what is the stationary points. Therefore, by solving the dou by dou x is equal to 0 and dou by dou y is equal to 0. By solving this two equation, by equating is equal to 0, you obtain that x is equal to 12 and 8 is equal to y is equal to 8 also value. By using this is the stationary points, when we are going to replace here r t s or r s t, and with the help of this equation, clearly rt minus s square is a greater than 0 and r is a less than 0. That is nothing but the function is a maximum. According to the working rule, whenever it is rt minus s square is greater than 0 as well as r is less than 0, the function is said to be maximum. Here the maximum at the point of 12 comma 8. Therefore, in the equation when we are going to replace, it is a x is equal to 12, y is equal to 8 and z is equal to 4. Therefore, it is clearly the equation is satisfied. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.